Hello everyone, this is Aditya, and today we are going to see how to prove the area of triangle using integrals. So before that, please do like, share, subscribe my video, and please subscribe my channel and please support this video so that it can reach to maximum number of people, because I am putting lots of efforts to make such kind of videos. So it's a request, please subscribe to my channel and please support my channel. So now let's start with the video. Okay, so how do we prove area of triangle using integral? Well, we know many geometrical methods to prove the area of triangle, but today we are going to see area of triangle using integral. So let's see. So suppose I assume a coordinate system like this. Okay, this is your y-axis, this is your x-axis, right? Okay, let me write it as capital X and Y, block letters. Okay, suppose this is your y dash and this is your x dash. Okay, and now assume that there is a scalene triangle, and of course I will be calculating for a scalene triangle so that the area is generalized for any triangle, right? Suppose this is your triangle. Okay, and suppose the coordinate of this point is negative b comma 0, where wait, and this is a comma 0, and suppose this point is 0 comma c, right? You could have assumed negative c also if it was in the negative y direction, but for now I am taking the positive direction. You can do for this also, and notice that a, b and c are greater than 0. Okay, so now let's see. Okay, so of course we don't need this system over here, right? So it is 0 comma 0, this point. Okay, so let's divide this triangle into two regions. The first one, this one, and the second, this one. Okay, we got this region and we got this region. Okay, so I won't draw much because it would look messed up. That is why. So let me erase it. Yeah, so let's calculate the area of the first figure, right? So how do we evaluate this? Well, it will be a simple integral, but integral of what? Well, we need to know the equation of this line. Well, what is it? It's very simple. So we know that y minus y1 is equal to the slope times x minus x1, right? Okay, so what you can do is that y minus, you can assume this point c is equal to m times x minus 0, right? Is it correct? And what is the value of the slope? Well, we need to calculate this. Okay, so slope is equal to delta y by delta x, right? Okay, and I'm really sorry, I'm not well, so that is why I might sound a bit down, but please understand that. Okay, so let's calculate it is c minus 0, c minus 0 upon 0 minus b, which is equal to c upon b, right? So we got the equation as, we got the slope as c by b times x. So we got y is equal to c by b into x plus c, right? Okay, so this work is done. So we are having the equation y is equal to c by b x plus c, right? Okay, let me erase this thing and then we will solve it. Okay, so now let's evaluate the area using integral and let's see what we get. Okay, so we can find the area as the integral from negative b to 0 of the quantity y dx, right? Which is equal to negative b to 0 of the quantity c by b x plus c dx, right? Okay, now you can evaluate this c by b into x square by 2 plus cx, right? C and b are just constants, and this is negative b to 0, so you get you substitute the value as 0, you get 0 minus c upon b into negative b by 2, I mean negative b whole square by 2 plus c into negative b, right? You get this thing. Let me solve it over here, right? Okay. So let's see, we get 0. Let's remove the 0 for now. Negative of c by b into b square by 2 minus cb, right? So you get negative of cb by 2 minus cb, which is equal to cb by 2. So the area of this triangle, the first one, I mean, of course it is a right angle triangle. So area of the first triangle is equal to half CB, or first figure is equal to half CB, right? Now let's calculate the area of the second figure. Let me erase this. So before knowing the area, we should know that what is the equation of this line. Why? Because what does integral say? Let me explain it also if you are not understanding it. That if you have this area, suppose from here to here like this, right? And you need to find the area under this curve, and suppose it is given by y is equal to fx, then the area is given by the integral a to b fx dx, right? You all know this, okay? So similar thing we are doing over here also, right? So let's see the equation of this line now. Okay, let me erase this. So let's see, y minus y1 is equal to m times x minus x1, right? We are getting this, okay? So let's assume again this point. So we have y minus c is equal to m times x minus 0, right? So y minus c is equal to mx, right? Now what is m? Well, again we will calculate it using delta y by delta x. So you get c minus 0 upon 0 minus a, 0 minus a, right? We get this thing, okay? So we get negative c upon a into x. We are getting this thing, okay? So it won't be a x over here. So we get the slope as negative c upon a. So we get y minus c is equal to negative c upon a x, which means y is equal to negative c upon a into x plus c, right? Okay. So let me write the equation over here. So y is equal to negative c upon a x plus c. Let me erase all this, and then we will evaluate the area. Okay. So now let's evaluate the area, right? Okay. So we get the area is equal to integral 0 to a of y dx. So we get the integral 0 to a. What was y? Y was equal to negative c upon a x plus c dx, right? So this is what we are getting, and I hope that you are understanding it, right? Is it understandable? It is very simple actually, okay? So let's evaluate this integral. We get negative c upon a x square by 2 plus cx. The limits are from 0 to a, right? So you substitute the limits. Of course, when you will substitute 0, it will be 0. So we just need to check for a, right? What we are getting. So negative c upon a into a square by 2 plus ca, which is equal to negative ca by 2 plus ca, which is equal to ca by 2, right? You get this thing. So the area of the second figure or triangle is half ca. So what is the area of the triangle, the complete triangle? It is the area of first plus area of second is equal to the area of complete triangle, right? Complete triangle. And for simplicity, you can name it as a b c. Of course I did not name because it wasn't necessary, but right now I can. Okay. So the area of triangle ABC, or any triangle, just you can name it as triangle, is equal to half CB plus half CA, right? You get this thing. So you get C by 2 into the quantity A plus B. And what is C? C is the height of the triangle, right? So, and what is A plus B? B is this length and A is this length, which means that A plus B is the base length of the triangle, right? Upon which the altitude is dropped. Okay, okay. So it is basically equal to height times the base by 2, right? Hence, the area of triangle is half base times height, right? Hence proved, right? So it is a better way to prove the area of triangle without using geometry if you don't want to use geometry actually, right? Because it is simple calculus, you're just integrating and getting the answer using the fact that the area under curve is given by the integral, right? The using the constant integral a to b fx dx, right? So I hope that you enjoyed this video, and if you did, then please do like, subscribe my channel, and please support this video and please support my channel so that my channel can grow, because I'm putting lots of efforts to grow my channel and provide you the best content. And of course, if you enjoyed this video, please support it. Bye bye, take care.